We were looking at arithmetic sequences. Now we're going to look at the second most important, I guess, or maybe I should say the most common that are tackled as we move into calculus. It's a geometric sequence. So arithmetic, what we saw was that we kept adding the same number to each term in the sequence. Well, we have a similar idea. Now what we're going to do is we're going to multiply each term by a common ratio. So we're going to keep multiplying by the same value. So if we find this ratio, what we're going to find is we're going to check each iteration and compare it to the one before, and we're going to see if we, by dividing them, if we get this common ratio. Here's what I mean. So for A here, I'm taking the second iteration, and now instead of subtracting it from the first like we did with arithmetic, we're dividing it by the first, and we get a value of 2. Now we move to the third iteration and the second. 4 divided by 2 gets me 2. 8 divided by 4 gets me 2. So what we're seeing here is that what's actually happening, this common ratio is the value which we keep multiplying each successive iteration by in order to create the sequence. Now if we look at the second one, B here, we're going to divide the second iteration by the one before it. That gets me 1/4. The third iteration by the one before it, 1/3. So I automatically know that this does not, or I can instantly see this doesn't have a common ratio. This isn't a repeated multiplication by the same value. So because it is not a geometric sequence for the second one. So we try this here. Let's see what we do. So we're going to get 10. We're going to do the second iteration divided by the first, and I get a value of 2. Let's try the third iteration by the second. So we're always the iteration by the one before it. Well, this is going to be 3/2, so this is not geometric. It is not the same ratio. Okay, let's try another one. So we're going to do 20 divided by 100. That's going to get me 1/5. Let's try 4 divided by 20. It's going to get me 1/5. And then we could keep going here. So you keep change flip. This is going to be 4/5 times 1/4, but it's going to be 1/5. So we keep getting this common ratio. So this is a geometric sequence. Okay, so this is going to be pretty straightforward. This whole video is going to be pretty easy. It'll step up in our second part here. But so we want to write a first 4 terms of a geometric sequence. Well, we have the first term, and we know that common ratio. So all we're going to do is repeatedly multiply. We're going to do, well, we know the first one. So the second one now is 5 times -2. We get -10. The third one now is -2 times the previous iteration. So -2 times -10. That gets me 20. Then we're going to do -2 times 20. We're just taking the iteration prior and multiplying it by -2 every time. And here we go with the first 4 terms of that geometric sequence. All right, so same thing again. I've got A1. So if I want to find A2, I'm going to do 18 times 1/3, which is going to give me 6. Now if I want to find A3, I'm just going to take 6, and I'm going to times it by 1/3, gets me 2. If I want to find A4, I'm going to take 2, multiply it by 1/3, I get 2/3. A to the fifth, or the fifth iteration, I'm going to take 2/3, multiply it by 1/3. Just repeated multiplication, so I'm going to get 2/9. Now put it down here in set notation, and those are my first 5 iterations of the geometric sequence. Okay, that's it. That's all we're going to do to start us off here. We'll take a deeper dive into this in the next section, but that's a brief introduction of the geometric sequence.